Hello, everyone. Hi, my name is Renato. Let me just mute myself here. Hi, this is my first time streaming here, so I would like to welcome everyone that is watching. The idea of this series that we're starting now is to basically go over the things that we notice our users are usually struggling with. My goal is starting with like forum questions, seeing like what questions we can solve together here. I can show you the answers. I can go through, try to fix it. If I can, if I can't, then I'll try to find someone that can, and in the future streams we can solve it together. But I do have some questions prepared, and if time allows, at the end, I will try to go over like setting up a robot or something like that. So every week there's going to be a different person and a different topic on the Isaac Sim series. This first week, what we want to focus on is importing a robot and making sure that the assembly works correctly, tuning up your simulation. And I selected a few questions on that, but if you have yours, please feel free to send it on the chat. We can try to take a look at them. And yeah, so this week it is going to be me. Next week is going to be someone else from our team. And unfortunately, this time we couldn't set up the dual stream with Twitch and YouTube, so we are only on Twitch this time. But in the next series, we hope to have everything else solved. So yeah, let me get started here. So I have some questions that I reserved for us. Let's start with URDF import, velocity and effort limits. I will open this here. Let me share my screen. Sorry. So here. Oh, it doesn't like Chrome. Okay, so I'll try to do that. So let me push this here. Okay, so for everyone that is on the call, if someone can just confirm that you can read on stream. But yeah, the question here is, does the URDF importer support velocity and force torque limits for joints? They have a URDF file in which the joints have a specified velocity and torque limit. So by that they mean here, this limit effort has an effort and a velocity parameter here. So yes, our URDF importer should do that for us. Let me share here. I had this that I have prepared for us. This is an example that we have in our assets. This is the UR10 URDF. And you can see that every link, every joint that we have here has limit, upper, lower, velocity, and effort, just like the one in the question. And if we go on Isaac Sim, let me load that up. So I'm going to load it from here. And once that loads up, it should show here. Okay. So bring this up. And if we come here, window Isaac examples, we do our import robots, UR10, URDF, load. So this is the example loading, but it will be the same as coming on the tool itself. If we come here on the UR10 that was imported, we come on the joints. We can see here on the property, we have our upper and lower limit, 360 degrees, a slight minor difference here because of the conversion from radians to degrees. But here we have max force as it was on our URDF 330, but we don't see the velocity here. And why is that? Because that is a custom parameter from the physics. However, if we come on the raw USD properties, we come here, maximum joint velocity, 120 degrees per second. And that is it here. So it all imports everything. And just to show the usual workflow for importing this, we could come on Isaac utils workflows URDF importer, and then here input file. Let me copy the directory for that one. Copy path. Just gonna paste it here. Okay, so this is where the UR10 URDF was. Just import. And here's the new UR10 that we just got. Oh, let's do it again. No worries. Here we go. Base link, shoulder joint, and this should be for all joints, but let's go on this one. Yeah, max force 330, and also on our raw parameters, the maximum joint velocity. So the URDF importer, as it is, it does import the efforts from the joints as well. One other question that we can have here: possible bug when creating ground. Let's go to that. Desktop. Okay. So I'll try to modify the friction parameters via the code. I noticed that these changes were not being applied in the environment. Specifically, I noticed that although material with the ground plane was being created, it was not being applied to the corresponding collision plane. And then they see that there's only as a core ground plane. There's suspicious, like a sus line of code. Okay. And that is 117. Visual material is not none, but physics material is none. Okay, so it is trying to apply physics material only if it's not defined. Yeah, this is very sus indeed. Let me search for that in our code base. Okay, let's go to VS Code. And here, groundplane.py. Indeed, if physics material is none, apply. And this is very sus. This should be is not none. And if you do this fix yourself, you can open your on your installation of Isaac Sim and go on the Python file and change it directly. And this should work from there on. For us, this is going to go on the next release only. So we appreciate for submitting the bug. I will put a tracker internally for this. And for next release, this is going to be fixed there. Yeah, and please, if you see this kind of thing and you would like to share this with us, we really appreciate that. This is a kind of feedback that really helps our product get better. Okay, what else? Okay, so I have another question that I had prepared here. Applying April tags on the racks of a thing. Let me go back. Desktop. Okay. So I wish to apply April tags on the legs of the racks of warehouse. There's a built-in April tag, but how to apply different tags and how to apply tags downloaded from the internet? Oh, let's do that. Let's find an April tag here on the internet. Tag. Let's get some image here. Any random single April tag image. This one. Okay. Save image as. I'll save this on my downloads in a folder called my April tag. This would be, oh, okay, so it's actually, let me just double check that it's correctly, because I did change the type. I'm not sure. It's my, oh, it's, I wasn't in the right folder, okay. My April tag. Okay, the image loads correctly. So let's go ahead and go to Isaac Sim now. And here we are. Here. Okay, so the thing is, they wanted to put this on the rack of the warehouse. We could pick any asset that we want here, but just so we keep consistency with what was requested, let me just go on the browser here for our assets, window, assets. And I'm gonna bring whatever rack I want here and just place an enable tag there. Okay, so let's find some asset here. And remember, these assets, because they were curated for the USD Composer, they are in centimeters and not in meters. So they're gonna be huge. They're gonna be 100 times bigger than what an Isaac Sim environment would expect them to be. So we just have to get them and downscale them back to meters. And because they have no physics, they have no other assets, we can just use the scale tool, reduce that by 100x, and it should be good. As it loads, is there any questions here? I don't see any, but yeah. Okay. So yeah, sometimes taking those, loading those thumbnails, it may take a while. So just have some patience and it should load eventually, hopefully. Just double checking because I did ask on the VS Code, but not for Isaac Sim, if the font size is big enough. So this is taking too long. I don't like that. We'll reset. Okay, resetting. Okay, so I'll do something differently then. I'll just go and say, okay, let's say we have a crate here. This crate is going to be this cube. And we want to add an April tag to it. And the thing is, if you wanted to like add as a texture regularly, this would cover the entire cube with that. So let's try doing that and see what happens. If we create here material, Omni PBR, and then here on the Omni PBR, we pick our, where's that? The albedo map. And on the albedo map, we select our April tag here in my April tag. As part of the albedo map, it generates that on the entire cube. And this is how you assign a material that has a texture to it. But the problem is it did pick our entire cube for that. So what we need to do is actually, instead of applying this directly to the cube like this, we create a subframe to it. So let's say our cube now is actually going to be part of this transform that has this cube and has another cube in it that's going to be 10 centimeters wide, 10 by 10, and actually 10 by 10, and this is going to be 0.001. So it's going to be like a tiny label that's going to be on the surface of our cube here. Just make my scrolling not so sensitive, so you can like put it on the surface here of our other texture, and then here we can apply our material that has the April tag, and then we can place this April tag however we want on the cube. But if you want this on the entire cube, that works as well. But this is one way of applying a texture on a small component of your cube. Alternatively, you would have to go on Blender, set up UV maps, and then downscale your April tag to that specific point. But I think this is an easy way of putting an April tag where you want without too much effort. Just get a single mesh that has a cube there, apply the April tag, and put it here. And if for some reason, I didn't check, but if for some reason this is rotated, which shouldn't matter for an April tag, but if you need, you just come in and rotate it however. Okay, cool. What else can we have here? Let's go to the other questions that I had prepared. Segmentation of fault when importing a USD file. Okay, go there, desktop again. Okay, in a Python standalone application, I'm trying to import a stage that I created using the GUI, saved as a USDA file. So it is a simple 4-line script that does stage open, path to stage USDA. That seg faults. Let's see what happens here. I will save this as our USDA file, save as. This is gonna be on here. Downloads. Actually, inside my April tag, I'm gonna use that. Set my April tag. Cube April tag. Let's do this USDA. Okay, save. All right, so let's open our Visual Studio Code. And then here, I'll stop the other Isaac Sim, and I'll just do standalone. And let me increase. Okay, so here we have our Python terminal. So I'll just copy what they had there from Isaac git import simulation. Should start our Isaac sim. So hopefully I did load this before, so it doesn't have to compile all my shaders again. Otherwise, we're gonna be stuck here for 5 minutes as it does that. If it does that, I'll go for a second question and try to answer that as this one loads. Indeed, it is compiling my shaders. Okay, so let's move ahead to another question as it does that. Okay, let me find here. Robot floating after import. That is a new one. Okay, I have some problem when importing a robot from URDF. The problem is that the model is just floating in space and therefore not being able to move around. Wonder if it's just that when importing, nothing else happened. It was not doing any, like, didn't add a ground plane. Maybe just adding a ground plane would fix that. I have imported the URDF using the URDF importer extension with the fixed base flag turned off, and then configured most of the drives as appropriate. A physics scene with gravity is also present. Okay, so apparently, yes, it is just that the robot, whenever you hit play, it is going to fall to the ground. It's not going to do anything else. Let's see. Do I have? I'll start IsaacSim, a second instance of IsaacSim as it's compiling there, and try to share that one. Go ahead here, import. I'll just do the same UR10 we did before. Actually, let me do it through the workflow so I make sure that I don't fix the base. No, fix base. Robots, UR10. Okay, so yeah, we have the robot here. Hit play, this is gonna fall to the ground. One solution for that is, for example, if you're doing a moving base, a mobile base, and you don't want the fixed base link, you should just create a ground plane and it should stay in place. Physics, ground plane. So whenever you hit play, robot now should be all set up. It's floating, but yeah. And then if you try to lift something, let's do shoulder lift joint. Actually, yeah, it's actually rotating the base because it is less effort than doing everything else. Yeah. Is the other one finished? Not yet. Okay. So yeah, and if you have some sort of mobile base here, let's see, do we have any mobile base? We have Carter. So let's import that. Stop simulation here. Same idea. So as long as you have a ground plane, it's not gonna fall to the ground because there is a collision there. Oh, I clicked the wrong button. Oh, I got an error. Interesting. Wonder what could cause that. Okay, this time it worked. Maybe I didn't pick the right folder there. Okay, then if I hit play, it falls to the ground, and then I should be able to control it. From the chassis link, right wheel, left wheel. And here's an interesting tip. If you select multiple joints, you're gonna see, oh, this one does let set the velocity here, but you see that it doesn't change until I release it, right? And even though here it has stiffness, okay, let's forget about that. But even here, it does have a velocity there, but it doesn't change until I release it. But if you go here on raw USD properties, skip multi-selection, and then change the target velocity here, it actually applies it instantly. So this is a quick way for checking things if you want to see things moving on screen. Okay, I think the other one is done, so we can close that. This one, yeah, just place a ground plane, and it should not float anymore. So let's go back to the other scene. VS Code. And then now from import USD. And now stage. I forget what it was. Let me find it here. April tag, my April tag. Didn't crash. Oh, okay. So yeah, just trying to make sure that it gets the right thing. But I can see that when I print stage, it does show cube April tag, so I think it is correct. Yeah, so apparently not an issue. I'll just ask them to double check if the path to their stage is correct. Otherwise, all good. And I do have one last question, and then I can move on to just show importing a robot from state, like from zero. So what I want to do is imagine that you have like a CAD file from a robot, and you want to import that. What are the best steps to follow in order to get it? Go and do that. Okay, let's go to the last question I had here. How do I import a USD file from my local disk in the Isaac Sim via Python? It is like a rigid plane. I tried different APIs like geometry, prim view, xform prim, but it does not show up during visualization. How do I import it from my local disk? Also, when I say the imported URDF to USD, apply articulation view, it throws an error. Okay, I think what is happening here is that when they say import a USD file, it is actually adding as a reference because otherwise it doesn't, or maybe it is part of the core API um, classes here. So geometry prim view. This is, I think it is a core API. So what I think, this is one question that it is kind of open-ended. We don't understand what is going on here. So I actually need to know from the user like what they actually are asking because I'm confused. I see a question here. Still text. I think Vulkan flag can help with the sheet compilation time, or does it come with any downsides? I think it is always Vulkan, isn't it? If I'm not mistaken, we always use the Vulkan for Omniverse. But yeah, on this question here, I think we need some clarification what exactly the user is doing. So I'll just ask that. Can you elaborate? Trying to do. Some code example should help. yeah, this is it. So yeah, let's move on to uh, the second aspect of what I wanted to show today, and that is I know that there's sometimes people asking like, okay, so how do I actually set up my robot? I have this CAD system, this CAD file, but it doesn't have all the joint attributes. It is a step file. It loses a lot of information as it goes. So, what is the best way of doing that? And for that, we can go to like websites and get some CAD files for examples. And what I'll do is I'll go on the Universal Robots that we can get support files. They have all their CADs here. And I already downloaded it, but if you search for it, you can get like the UR10, UR16 CAD files. They come as JT types. And while you could import this directly, I actually chose to import this into my Onshape account so that we can set up all the joint attributes for it. And I have it open here. I think it just has to reload. But the Universal Robots CAD files, they are actually very good because you can see that they come very well separated. Every part of the robot is already a component on itself. So this makes it much simpler for us when we import it. And actually, we could already directly import this into IsaacSim, but it would come as just an empty model. It wouldn't come with any of the joints set up. So to do that, we can come here on the assembly and we can set up the joints here. So I'll start with the ground, the base. So let's hide everything else. Fantastic, it doesn't let hiding everything at once. And here I will start with setting up my Revolut mate. Get this one, and then this one. It's already connected. And this joint has limits minus 360 to 360. And we keep on doing that until we finish the robot. This is a simple robot to do that. I do have another example that I already have done that has more complex geometry, and I can go and show that. But let's just finish this one first. It's not too too long to do that. If I recall correctly, UR16 everything is minus 360 to 360. So you can go ahead and yeah, keep doing that until we're finished. This to here. Oh, what happened? Oh no, it didn't do that. Okay. So we have 1 and 2. Okay, let's go ahead, go back here to this one. Now show this, hide this, do this one. Okay, and our limit minus 360 to 360. Next joint here. Now this one. And hiding is the most effective way of finding the surface that you want to add the mates, because then you can easily find that. Limits minus 360 to 360. Okay, final one. Okay, let's unhide everything. And here, what we expect now is that whenever this robot is imported, all the components should come as their own rigid bodies with the properties that we can collect from OnShape. One thing that I wanted to make sure here, we can already come with some predefined inertia matrices computed, but we need to go item by item and assign some material to it. Unfortunately, because it is not a complete CAD system, this is going to be an approximation on weight and whatnot. But this can be fixed with UR10 properties later. I think UR10, UR16 in this case. I think Universal Robots do provide complete specification for every individual component. But for now, we can just set up this as aluminum. Can I do that for multiple objects at once? Not sure. Assign material for 6 parts. Yes, let's do that. Okay, so now this robot should be imported with some mass properties and everything. So let's go to ASICSim. Do I have it open still? I don't. Okay, let's open ASICSim. Okay. Now, okay, here we go. Let me just adjust the size of the screen here. Okay. And file, import from OnShape. And you can see like it brings all my assets here. Because I was already logged in on my browser, it just automatically picked that for me. Here's our UR16. If I double click this, it should import it. And you can see it picked my aluminum material, some messes here. They're definitely not the right messes for the UR16, but at least it comes with the inertia matrix that is somewhat accurate to what the robot would have. And one thing you can notice here, because the CAD file was with the robot pointing up, this is the default pose that it comes for us. If we needed to change that, because as I remember, the URDF comes with the robot actually tilted 90 degrees, we can change that directly on OnShape before importing, and it would assume that is the base pose. It doesn't change the limits. The limits will apply as if that is the base pose. Just for clarification on how the importer works, and this is based on the OnShape API. So here, one thing that we need to do here is just make sure that we fix our base. Let's do create physics joint, fix joint. And then as we simulate, robot is completely articulated. It doesn't set up the drives though. So as you can see, robot is flopping around. So what we need to do is select our joints, and then all the upper limits, lower limits are correct. We just need to add our angular drive. And then this would be configuration just like the URDF. Add a damping here, stiffness 1A5 and 1A4. And then as we go, if we try to simulate it now, I can do the trick of skip the thing. And if I go on target position, you see that the robot is completely set up. So one thing that I wanted to show on the other gripper that we had, let me import that one as well, is some post-processing that may be required depending on your robot structure. Besides like this whole setting up the drives here, here's my gripper. If I open that, if I import it, here's the gripper now. One key thing about this gripper, as you could notice from the robotic, And this is also a step file that you can get from Robotic website. One thing that you notice here, we do have loops on the simulation here. So you can see we have the base here that connects to this gripper, to this link. And this link connects here and back here. So we need to make sure that for this to simulate correctly, we need we need to go on the joint that connects those two bodies, either this or this one, and remove from articulation so that we have a tree hierarchy instead of looped hierarchies. And because I know that this gripper is supposed to be controlled by those two joints, the ones that I would choose to remove from articulation are those two instead. So I'll select them here, go and exclude from articulation. And if I run simulation now, except from this falling to the ground, let me just add a ground plane here, just so it doesn't drop. Because later I want to compose this on the other robot. But yeah, let's put this here. You're gonna see it drops, simulates, sometimes it explodes, kind of how it goes because it is not properly tuned. But if we come here now, I actually have this already tuned on another other version that I imported. Maybe it's better if I just bring that one instead of retuning this, and I can show what tuning parameters I did. So let's go there. This is it's not a mount. Where did I put that? I forget. Oh, it's not a prop. Oh, it is in robots. Okay, yeah. Robotic 2F140. So I bring this here. So it is the same asset as we had there. The only difference is I played with the materials a little bit, so it looks more metallic, looks a little bit flashier. But if we go on the joints here, we have all these joints. I set up their limits so that they work correctly. And for those two joints, they are essentially the same joint. I just disabled from articulation. There's no drive on those joints. Actually, for this robot, the only joints that have drives are those two. I set them with the upper limit of 130 degrees, so that makes it open close the right way. Some damping, some stiffness, so this is position controlled. And that was it. Everything else here, if you go to the other joints, I set some limits to those two joints as well. Okay, I forgot about those. Yeah, those two joints, they also have limits, but they don't have drives. They have just a small stiffness to make sure that they comply better. But all these other joints, they're just open joints. They're limited by the rest of the hierarchy of this gripper. So one thing you can do here just to try is I'm gonna fix this in place. Where is my base here? This is my body, okay. Create joint physics, joint, fix joint. So this fixes to the space, so now it doesn't drop. And you can see like I can play with it. Right click, right shift, actually left shift and left click. You can drag things, you can apply forces, and you can see that it reacts. Let's create some mesh here. Maybe like a cylinder. This is a huge cylinder. Let's scale this down 0.088 centimeters. Let's place this around here and make this a rigid body. Okay, so now we can come here on our gripper and we can close it. Target position. And you see that it grips on the body. And that's why we have, yeah. Just make sure that you don't go too much over the under position, otherwise simulation destabilizes like this. Yeah. And this, if I lift this body, it should probably, oh yeah, because this just moves everything. However, yeah, let's go to the final part, is composing those two together now. So what I would do here is I get this object here. I would drop it on my link 5 and reset the transforms. Interesting. This transform is broken. Okay, that's good to know. The transforms for the on-shape, they are not in the right place. But yeah, if it were, this would connect to the right dots here. So this is something that whenever you import from on-shape or from whatever, just have to make sure that the origins for the objects are in the right place. Otherwise, it's going to break. And because those parts here, if you go here, yeah, they are not exactly aligned. You see, they're all, well, this one is, but link 6. Okay, let's see link 6. Link 6 is the one that I wanted to join in. So let's try that. Yeah, there's also the transform. Oh, yeah, this transform is kind of broken. Unfortunate. Let's see if maybe inside of this one I can get it. No, yeah, this is also not giving the proper alignment. So this is one thing to make sure that whenever you're importing this, just be sure that you assign the origins to the right places. And you can see that all these parts, they are not in the origin. So whenever they get combined, it ends up, yeah, you can see that the origin is not at the object origin. So they're all kind of messed up. So one thing to do is before importing, just make sure that you clean this, align it together, and that should be it. Maybe we can report that. I think we have time for this. Okay, let me. Okay, base is correct. This one. Let me. The way to fix that is let's fast animate here. Move this together. Okay, we don't need this anymore. We delete it just so it aligns. Okay, let's do that for everything. This one, I don't know which part is bottom. Okay, bottom is this one. Delete this fast animate. We don't need it. Make sure it's aligning to the X direction here. Okay. And for link 6, same thing. Um, Just make sure that I don't have any leftover mates. We don't want those fasten mates to be messing up with the rest of the import. Okay, I think it should be good. So now let's delete this, import it again. File import from Onshape. Okay. Now let's add a drive to those joints again. And then let me drag my gripper again at my link 6. Interestingly, it didn't update that. It should have though. Or maybe it didn't update the version that I was trying to import. Yeah, that should have updated the positions here. So let's see. It's just maybe what I can do is just to be sure that I have a new version, just create a new v2. Come on my importer. Reload this. Your 16. Let me delete this one. Oh, because I deleted it. Okay. We have a new URT here. let's redo this. I did too many things at once. Here we go. This piece. Yeah, it's still broken. Broken origin here. Interesting. Should have fixed the origin. Let me see. Is it? Yeah, this one it does seem in the right place. Maybe it is some cache thing. So let me try to restart simulation. Restart the Isaac sim. Okay. Let's try again. Import from Onshape. Hopefully now it gets the non-cached version of it. I think 1, 2. Yeah, it doesn't seem like it. Doesn't like that the updates that I made. Maybe there's more that I need to fix on the model for it to get the right origins here. It's been a while since I last did that, so don't recall this correctly. Let me go to the desktop again. Let's see. How can I see where the origins are for the pieces? Or what I could do is place all the pieces again here. Let's see. I'll start a new assembly just so we have that one there. Then now I'll insert my pieces. Insert. My base. Link 1, link 2, link 3, 4, 5, 6. And we're gonna start from here. Okay, let's hide everything. I'll fix my base in place so that it doesn't move. It is on the origin. Actually, I have to fix this. It doesn't let me fix the assembly itself. Oh, that's it. It moves the pieces and not the assembly, because that's how OneShape does things. So let's hack it away. Let's create groups for every individual assembly so that when we move it, it moves the entire assembly out. Okay, so now let's go to our Revolute. From this to this. Okay, Revolute 2. From this to this. Oh, it didn't pick the first one. Let's restart. From this to this. Okay, limits. Minus 260, 260. Now, this to this. This one. Yeah. Okay. So now this to this. Or is it that? Let me see again. From this one, okay, so it should be always on the black ring at the end. Okay, so this. Limits. Minus 360, 360. Minus 360, 360. And one from here to I feel like I'm missing something. Oh no, it's just that the orientations are different. Okay, so this needs to go up. Okay. I'll finish this and then I'll fix that. Okay, so here's another. Okay, this is fixed. So now this one, just have to make this go up, and to get the same orientation as this one needs to be pointing here. Okay, all right, this should fix it. I didn't put limits on all of them, so let's double back and put it. And you can see if there's limits or not by this icon here. Okay, so let's go back to Isaacson. Let's try this one more time. So yeah, it is missing the new assembly that I did, so it is caching things. Okay, new assembly. Ah, this one I made pointing on the same way that the URDF usually shows UR robots. And I did forget to make this visible, so but it did import it, so we just have to make it visible here. Same thing for others. Oh, and because it is all in groups, now things are kind of hidden away in the groups. Let's undo that. But before doing that, let's just double check. Okay, origins are in the right place now because it did move everything together. So let's undo all these groups here. I just deleted the groups on Onshape. I will re-import it just so it doesn't come with this messy hierarchy. I'll also make things visible so that whenever it's imported, it brings everything correctly. Okay, yeah, now we have the right origins here. This is good. This is good because now we can use this to make our gripper go in the right place here. So let's, the way that I usually compound grippers here, we do have a gripper composer that is alpha in the release. But if you're not familiar with that or wanted to try the hard way, because for me it is easier because I'm just used to that. But usually what you go is you pick the gripper now, I put it on the place here, and then I make the joint between them. So here, robots, robotic. Let's place it inside here. So it comes misaligned, but we can add our transforms, translate, orient, scale. It is rotated by 90 degrees, so 90 degrees negative. Okay, so now we just come here and we push it here out. And this is a gripper for the UR10, not for the UR16. But I guess we're just making, like, trying things out. We don't need much more than that to try things out. We just place it here, and then we move it out of the assembly. So it needs to be its own thing. And then now we pick our link 6, that is our rigid body, and our robotic base. So this and our body here. Create physics joint, fix joint. So this should put them together. One thing though, because the gripper is an articulation by itself, just make sure that we select exclude from articulation when compounding them so that they can be individually controlled. And if I hit play here, everything should fall. No errors though, so this is good. So now let's go on our base, create physics fixed joint, and then we have our gripper there. And because it did flop around too much, physics did break. But if we go back here, set up our drives, physics angular drive, 186, 184, just some regular parameters here. Then now I want to control this. Okay, nothing breaks anymore. And we can have a target position. And we can see robot is composed. And that is it. I see a question from Twin Snakes. I'd like to know more about Isaac Sim Gym. I'm new to this technology concept, and I want to know how it can help me with physics simulations. Yes, Isaac Sim and Gym. This is our simulator for robotics. It's leveraging the power of Omniverse in general, which comes with physics as the base for physics simulation. And it is essentially a specialization of Omniverse for robotics. And the Isaac Sim is the whole aspect of it, and Gym is the component of Isaac Sim that gives us training for reinforcement learning environments. So there is a component of Isaac Sim that helps you setting up all the environments that you need so you can pick your learning algorithm and do training with it. And I do have one presentation that was done for GTC a few weeks ago that explains how the whole architecture works. It shows all the tools that we have for Isaac Sim, the sensors that we can simulate, how to like go about the samples that we have. I can probably go over some samples here just to show a little bit of what we have. But yeah, and this GTC presentation, it is free. All you need is sign up on the NVIDIA, sign up for an NVIDIA account, and then go over the video on demand sessions and find the Isaac Sim, like an introduction to Isaac Sim. It is currently available only for people that have previously registered on GTC, but in about a week or so, it should be available for everyone that goes on the website and search for best presentations. I need to find the link. I don't have the link on me, but let me see if I can find it here. Yeah, on demand. Okay. Yeah, on the NVIDIA on demand, I only see the press presentations. Let me see if I can find. I do have the link for my presentation here. I can paste it on the chat. Just give me a second to find it. Okay. Here we go. So if you have access to the GTC conference, you should be able to go through this link. Oh, I have to. Oh, okay. Wait a second. I'll ask for someone to paste it here. Oh, got it. Okay, so you were registered. Cool, awesome. So you have access to it. I'll see. Paul, good. Here. Let me see. I had someone on the Discord call with me. Okay, they're gone. So hopefully, Edmar can paste it on the chat for me. I am not logged in right now, so or if you are on Discord, I can paste it on the Discord channel. I pasted it on Discord channel, so if you were there, you can find it. Otherwise, let me see if I can log in quickly here on my personal account on Twitch. Not to paste on the chat. Copy link. There we go. That is my personal account on Twitch. You should yeah, okay. I think that's what I had for today. I really appreciate everyone that joined and made questions and participated. Yeah. So next week we're gonna have another session of like that. We're gonna have someone answering to more questions from the forum and possibly doing some other demonstration about other aspects of Isaac Sim for you. This is what I had for today. Was mostly on building a robot, making sure that we import it correctly, going through the hurdles that sometimes it happens. We're trying to improve the tools as we go and as we find the use cases, but yeah, try to make it as seamless as possible as we go. But yeah, thank you everyone. Bye.